It'd be pretty entertaining.
It'll be okay.
It'd be entertaining. All right. So, for people joining us on YouTube, we have completed the first part of the worksheet. So go through the whole limiting reactant worksheet and just look at the pictures. And if you ever get confused, what should you do? What did I tell you guys to do? If you ever get confused on the actual math chemistry parts, look back at your stick figures and your drawings of N's and H's, and it will make so much more sense. All the math is the same. All right? So, if we have, now we're on question, applying the smaller amount method, right? So it's the second page. And this is the real chemistry now. If you took 10.02 grams of hydrogen and mixed it with 28.02 grams of nitrogen, how much ammonia will form? Wait, so which one's the limiting reactant, you guys?
Hydrogen.
So everyone right away is going to say hydrogen's the limiting reactant. Why? Because it's a smaller number. That's wrong.
Okay.
Why does that turn out to be wrong? Guys, what's the molar mass? I'm showing you right now why it's so important.
2 times divided by 3.
Why are moles so important? Because what does an N2, wait, what's the mass of an N2? 28 grams per mole. What is the mass of an H2? 2 grams per mole. So which one are you going to actually, though it says 10 and 28, and you're like, whoa, 28 is way bigger than 10. But when you actually count how many of them there are because of the weight, you're going to find out it's going to be a little different than you think. So let's start out. So if we have 10.02 grams of hydrogen, and we have 28.02 grams of nitrogen, we're going to use the smaller amount method, which means we're going to turn each of these into our product, NH3, and we're going to say which one are we going to run out of first, what's our limiting reactant. So our question is, which one of these makes less NH3? So, what goes on the bottom here? Grams of H2. What goes on top? What goes down here? And what are we turning it into? Moles of NH3, right? Lastly, what do we want to know? Moles of NH3, we want to know how many grams that would make us of NH3. Now, invariably, people are going to ask, do I need this last step? You can do it without and compare the number of moles, but you still have to do it in the end on the one that's limiting. So I just do it now. Okay? Next one. Oh, well, let's fill the numbers in here first. How many grams per mole? How many moles of H2 to moles of NH3?
3 H2 and 2 NH3.
Mm-hmm. And then how many grams per mole is NH3? 17. Okay, now, N2. What goes on the bottom? To moles. What goes here? Moles of N2 to moles of what?
NH3.
Good, again we're going to the same product. By the way, if the reaction makes 2 products, what should you do on both of them? Go to the same one. People will go to different products and then be all confused, right? Go to the same product, because you're directly comparing the 2. Okay, now what goes here? Moles, then H3 on the bottom, and then what goes on top? Now luckily this is the same number, right? What do we get here? 28 to 1. And what's the ratio? 1 to 2, right? Okay, so now let's do our math and find out Okay, did you guys get same answers as me? 34. So, which one did we run out of first? As we're making this, N2 is reacting with H2. Which one do we run out of first? At what point does it run out, by the way?
And the next one.
When it reaches 34.02 grams, we are out. We have used all of the, we've used all the N2 when we reach 34.02 grams. So what does that mean that this is? This is the limiting reactant. Right? So which is the limiting reactant? The answer would be N2. How many grams of ammonia could be produced by this reaction? What's the answer? We have 2. Which one's the right answer? Absolutely. It would be 34.02. We can't make 56.78 grams. Why? Because even though we have enough hydrogen to make that, we don't have enough nitrogen. Right? How many grams of the excess reactant were actually used in this reaction? Ooh. We got to do math now. Because if we made 34.02 grams of NH3, the question is, how many grams of H2 did that use? Do you see what we're going to do? What are we going to do? We're just going to go backwards. Why wouldn't I just write 10.02? Because it's not, we didn't make that much, right? We made this much, so we have to go from here backwards. So, by the way, kind of nice that we already know the numbers, right? What are we going to do here? Just backwards, right? And then it's going to be moles NH3, right? To moles of what? Okay. Specifically, remember on the test last year, people went from this back to grams of N2. What are you going to get? What's your answer? I can tell you right now without doing it. 28.02, right? And they were just really confused, right? You have to go from this number back to your excess reagent, your H2, right? So now, lastly, we're going to have moles, H2 grams, H2, and we are going to get 17, 1, 3 to 2, and 1 to 2. By the way, Taylor, is that on the screen?
Yeah, except for I think you can't write any past this, so it's right underneath.
Okay.
I think. Yeah.
Did you get 6? Should be about 6 grams. I was talking while I was calculating, so I got it right, didn't I? I'll do it again just to make sure we're right. Yep. Okay. 6 grams, H2. So that would be how many grams we actually used, question number 3, right? Now question number 4, how much was left over? How much H2 is laying around afterwards?
4 grams.
There you go. 10.02 minus 6. So this is how much we used. And then if we had 10.02 grams and we used 6 grams, what do we have left over? Leftover or excess, right? Man, that is so much fun. Isn't that great? It's a good question. All right. So there you go. Now you guys try it.